Hey, Papa, let's identify some rocks. All these rocks came from the eastern Blue Ridge, Inner Piedmont, and or Carolina terrain. So in the book, here we have the table that shows you what are all the possibilities for the EBRIP, which is Eastern Blue Ridge, Inner Piedmont, and Carolina terrain. These are geologic terrains. So mostly that's the Eastern Blue Ridge and the Piedmont area. There's a lot of possibilities. And you see over here it tells you whether they're felsic, which would be light colored, intermediate, which would be maybe speckledy, or mafic, or ultramafic. Light colored, speckledy, or intermediate colored, and dark rocks. So I've kind of organized them into piles: light colored rocks, kind of speckledy rocks, and then dark rocks. That'll help a lot. Now, we could sit here and analyze these rocks. I've cracked the ones that needed cracking so that you could tell, to make it easy to tell what they are. There's a cracker. That's a must. I haven't cracked most of them because their surfaces are good for identification. There's a cracky. This one was cracked. Anyway, you could just thumb through the pictures in the book and take one rock at a time and thumb through the pictures in the book for that particular province or group of province, and just find a rock that matches, because the book has really good pictures, and you can just compare the pictures in the book with the rock you have. There's not that many pages to flip through. You know from that list of possibilities that gray whack is probably not likely. Shale, no. Chert, you're probably not gonna find. Kaolin, you're definitely not gonna find. Limestone and dolomite, you're not. So you could flip through those pages. Coal, you're not gonna find, and then focus on the pages that are in your geologic terrains for rocks that you're identifying. So that's a possibility, but we're going to look at these rocks individually. And there's some trickies in here. Let's start with the light colored rocks. Look at this. Everybody knows what this is. It's a piece of sheet mica, Muscovite mica. That's a felsic mineral. This is not a rock, it's a mineral. You put two minerals together to get a rock, usually. And this is found in pegmatite granites in various places in the Piedmont, and probably the Blue Ridge too. And long ago they used to mine this stuff and they call it isinglass, and they made glass for lanterns. And they also may use it in electronics for insulation boards and stuff like that. It's a mineral, Muscovite mica, felsic mineral. How about this? Well, the first thing I notice about this, let's see if we can get it to do it for you guys. I don't know if you can see the flashy face there. Right where my finger is, I'm seeing a little flash. Let's try this side. No flash there. See that flash right there, bright flash? What has a flashy face? It's all the same stuff too. You don't see grains or anything like that. This is better. You guessed it. This is flashy feldspar, the mineral potassium feldspar. Flashy feldspar. Well, let's keep going. Most of you are going to know this. It's vein quartz. Quartz that forms as veins in other rock, which would make it kind of a metamorphic rock. But it's pure quartz. It's got iron, a lot of iron in it, and that's where the brownish coloring is. But it's mostly quartz, silicon dioxide, used in computers, and those little MOSFET transistors that are in every electronic device. Also, you grind it up, and it makes good beach sand. Okay, so we got 3 felsic minerals here. How about this? Would you like to, as a felsic rock, what minerals do you see? I see dark spots. That is very interesting. I see white spots. I see gray spots. Okay, if you remember our discussion on minerals, you know that white spots in a rock is usually feldspar. And grayish or clearish spots are usually what? Quartz. And I see little shiny, sparkly mirrors. Those could be muscovite. So that's probably going to tell you what the dark spots are. You're going to probably know that that's biotite, and this is granite. This is a rock called granite. This is Elberton granite. How do I know that? Because this thing says Elberton. I got it from the Elberton Museum, I think. And it's been, this end has been smoothed off. Maybe it was a piece of a tombstone that they were making. Granite, an igneous rock that starts off as a pluton underground, felsic igneous rock. It's squirted in between rock layers deep underground, and then erosion reveals it. So that's pretty easy. Look at this one. If you examine this guy up close with a hand lens, well, I can see the sparkles in it. If you looked up close on those, you're going to find those are there's muscovite in there. Look at this. See the white hunks in there? What could that be? So felsic rock, so it's going to have a felsic minerals. That would be, yes, feldspar. So we got mirror muscovite, flashy feldspar. So that's probably going to mean the black areas are biotite, and the, let's see what else. So we got biotite. Oh, and there's gray areas. Those are going to be quartz. So this is granite or something like granite, but it's got lines in it. Granite doesn't have lines in it. What are these lines? These are lines of metamorphic banding. If you see a rock that's granite, look, it's got the minerals of granite in it, except it's got these lines. You're looking at a metamorphic rock. So this is granite gneiss. Granite gneiss is granite that's been mashed by continental crashing, and turned into a metamorphic rock. And this looks like it's gone through a lot of meta, because it's really hard and crystalline is what it looks like to me. And they actually call a lot of the heavily metamorphosed granites crystalline rocks. So this is probably pretty old granite gneiss. Could even be 1 billion year old basement rock, which is the rock, the granite gneiss rock that formed the base of the continent, and all the other rocks are laid up on that. Okay, we're doing good so far. We've got 3 of the minerals that constitute granite. We've got granite and granite gneiss, its metamorphic equivalent, from the Eastern Blue Ridge Inner Piedmont, Carolina terrain. That's a lot of places. Okay, let's skip over these funky rocks right now and go to the dark rocks. Because we know dark rocks are going to be mafic rocks. Put them up here in the shade. I think you can see them better in the shade. I don't know. Oh, well, one of them over here that I had in the... Look at this guy. Based on what we just did, what would you say this rock is? Right, granite gneiss, because it's got white feldspar, it's got black, which we consider biotite. But why do we know that's biotite? We suspect highly it's biotite because we know that this white stuff is potassium feldspar mostly, and it's a felsic rock. A felsic rock is not going to have a mafic mineral in it usually. So we're going to call the black Biotite mica. So this is also a granite gneiss. I say a gneiss because it's got kind of a lines. It looks beat up a little bit. Now, if you find granite gneiss that's on the surface of the ground, it's not going to look as nice as this or this. And if you find granite that's on the surface of the ground, it's not going to look like that nice. The iron that's in the rocks will be oxidized, and there'll be a lot of brown. The rock will be kind of falling apart, and the sand grains, the quartz grains and feldspar grains might be coming out of it. Excuse me. So eroded rock is different. All these rocks came from in the ground, uneroded. Okay, so let's go to these darkish rocks. I cracked this one, and it's dark. So I wondered what the black stuff is. There's a lot of black stuff in this rock, black mineral in this rock. What can it be? Well, I know from my studies that if the black stuff is biotite, then my nickel, which is soft, but it's harder than biotite, should be able to scratch into this rock pretty easily, and I've scratched it. See the scratches? See that gray stuff? That gray stuff is rock dust. So my nickel has fairly successfully scratched this black stuff. That would make it biotite. Well, I know that biotite is an intermediate mineral. It's not felsic, it's not mafic, it's in between them. And so I would look for a rock that has a lot of biotite in it, and if I thumb through the pages in the book, I'm going to find a rock called Biotite Gneiss, Biotite Hornblende Gneiss. So that's what I'm going to call this, because it's got white stuff in it, which will be small feldspar pieces. A lot of dark, which I'm going to call biotite. That's about all I can see. It's got quartz in it, if you look close enough. But just knowing that the dark stuff is more than likely biotite, you're going to call this a Biotite Gneiss. And you can look, if you say, is this Biotite Gneiss, what minerals will it have in it? So let's go to the rock here, and let's find Biotite Gneiss. Granite, granite. Biotite Hornblende Gneiss, okay. Biotite Hornblende Gneiss, it's an intermediate metamorphic intrusive rock. Primary minerals are quartz, biotite, potassium feldspar, and plagioclase, which is sodium feldspar plus or minus, sodium-rich feldspar. It could have hornblende in it, which is a slightly mafic mineral. And then you look at the pictures. Okay, look at that one. That's kind of similar. This rock has bigger crystal sizes, grain sizes in it, but I'll go with that. Call it Biotite Hornblende Gneiss. So we got that one. What was Biotite Hornblende Gneiss? Biotite Hornblende Gneiss used to be the closest thing that it used to be is kind of magma, intermediate magma, maybe something like diorite, plutons, and it forms, or it could have been andesite lava, or it could have been those are the main things that it could be. It's intermediate magma / lava that you get a lot of during island arc formation. And we had island arc form in the Piedmont and Eastern Blue Ridge back during the tectonic mountain building event. So Biotite Hornblende Gneiss. Let's look at this guy. Well, I noticed definitely it's dark. It's very fine grained as opposed to, say, this one. Look how big the crystals are. This is very fine grained. And so I said, is that dark stuff biotite? Well, I scratched it with my nickel. Can you see those lines? Right? Let's see. Right in here. Right above my finger. Well, that's the scratch marks, but that's not, it didn't scratch the rocks. That shiny stuff is the nickel. So this is hard. This dark stuff is hard. That means it's going to be hornblende or even pyroxene, something like that. Amphibole, hornblende amphibole, which is a slightly mafic mineral, or pyroxene, which is a real mafic mineral. So this is a mafic rock. What other minerals do I see? I see light-colored stuff in there. that is likely going to be feldspar, but it's not going to be potassium feldspar, right? Because that's a felsic mineral. It's not going to be, probably not going to be a lot of sodium feldspar, because that is a intermediate mineral that you would find in the something like this biotite gneiss over here. It's going to be maybe calcium. It's going to have calcium in the feldspar, and I'll just call that calcium feldspar. It could have mostly calcium, but some sodium in the feldspar. Okay. So I'm going to call this, I'm going to have to call this, it's a metamorphic rock. I know that because it came from Eastern Blue Ridge Inner Piedmont, which is the metamorphic central. It's where there almost all the rocks there are metamorphic, and matter of fact, all of them are except for granite and diabase. And it's neither granite. We know it's not granite, and we know it's not. We can determine that it's not diabase. It's possible to be diabase, but I'm going to call its grain size is so small. I'm going to call it metabasalt. So you could also call it amphibolite, because amphibolite is a metamorphic version of basalt lava. If they know it used to be, for sure that it used to be basalt lava, they call it metabasalt. I'm going to call it metabasalt. It's got this weathered edge where a lot of the iron is oxidizing out of it. So it's iron rich, you can tell that. So also I see it's kind of greenish. That greenish is probably epidote, which is an alteration product of basalt lava, metamorphosed basalt lava. And I'm pretty sure this came from the Carolina terrain, which also was an island arc that crashed into Georgia. So we'll call this metabasalt with epidote. Epidote is a pistachio green colored mineral. Okay, doing good. Here's another Mafic rock, and it's got really black, dark crystals in it. It's got big white crystals in it. I didn't scratch it, but I'm sure that if I did, that the nickel would not scratch the black stuff. That means, because it just looks Mafic to me. Ha ha ha, that's real scientific. That's a technical term. Since the nickel couldn't scratch the black stuff, we're going to have to call it either hornblende or pyroxene. A mafic mineral. We'll call it a mafic mineral. And that means we're going to call the light colored stuff, calcium, mostly calcium feldspar, which is also a mafic feldspar. So mafic rock, dark, with big crystals. Well, let's look through the book. It's a pretty distinctive rock. Let's look through the book and see if we can find it. Mafic rock is going to be something like lava or magma. That looks kind of like it. This says Amphibolite. So Amphibolite is metamorphosed, usually metamorphosed basalt lava or gabbro magma, gabbro pluton. Gabbro, oh my goodness, look at this. Look at this. Metagabbro from near Eatonton, Georgia, showing the big crystal size that helps identify it. I think we found it. Metagabbro. What is gabbro? Gabbro is the mafic. It's the underground equivalent of basalt lava. Exactly the same minerals in them. It's just that the gabbro never erupted onto the surface, and so it cooled more slowly. The crystals got bigger, whereas the basalt version of it did erupt. There's a basalt version of it right there. So it cooled very quickly, and the crystal size is small. So you have what used to be gabbro magma underground and what used to be basalt lava above the ground. All this volcanic activity in the Ebrit really tells us that it was a volcanic island chain. Okay, let's look at this. knock this out pretty quick. It's beat up, but it's mostly lightish. I see a lot of white stuff, black stuff. What would you call it? It's just like got that granite kind of look, but it's also has metamorphic banding. So we're going to call it granite nice. Good job. Job done. Okay, this is going to be a hard rock to show, but you see all this shiny? What do you think that shiny stuff is? Let's see if I can get it to shine in the light. I don't know if that's better or worse. If you looked closely, really, I can tell just with my eye that shiny stuff is Muscovite Mica. So we got a lot of Muscovite Mica in there, but there's other stuff in there. If you look close in a side view, you can see there's a lot of quartz. Here's a piece of quartz sticking out right here. So there's a lot of quartz. So it's a mixture of quartz and Muscovite Mica, and it's all smashed flat. It's all smashed flat. When you see something that's smashed flat and it's shiny, call that schist. Schist. It's a metamorphic rock, and the reason that it's smashed flat and shiny is because of metamorphic pushing and shoving that smashed it and smeared the muscovite crystals out until you get this schist, quartz muscovite schist. Very cool. There's a lot of this in Ebrip, the Eastern Blue Ridge Piedmont of Georgia. And where did it come from? Well, the muscovite is former mud. Muscovite comes from mud. It can also crystallize in a granite rock, true, but if it's in a sedimentary or metamorphic rock, it comes from mud that's been subjected to intense metamorphic pressure. And of course, the quartz is sand. So you've got a sand-mud mix that was mashed and crashed by metamorphic pushing and shoving and turned into this metamorphic schist rock. Look at this guy. Similar rock. Oops, sorry. Similar rock, except look how reddish it is. If you look in the side close enough, you can see quartz grains, and like this. I don't know if you can see the muscovite, mirror muscovite shining. Quartz muscovite schist, same kind of stuff, but it's red. What is that red? That's iron pyrite staining. So you know that this quartz muscovite schist was exposed to hypothermal alteration. That means that it probably blew out of the volcano and settled the Island Arc volcano and settled down underwater on the flanks of the volcano, and then this hot water, which was pulsing in and out of the volcanic material, this material, mud and sand, pumped it full of iron and sulfur. Pyrite is iron plus sulfur. Just pumped it full of iron and sulfur and turned it this red color. And here's another one that's the same stuff. Look at the white stuff. The white stuff is sericite mica, and that's mica that's been subjected to hydrothermal alteration also. And the hydrothermal means hot water. Hot water from a volcanic vents, hot water from black smokers, that the black smokers blew their hot gases full of sulfur and iron and sometimes even gold up into all these sediments that were laying around the flanks of the volcano and flushed it full of iron pyrite. This I wouldn't say what got flushed. I don't know for sure, but it doesn't have that iron pyrite staining. But this does. This is an easy rock to identify for me because it's really pretty spectacular. And in the old days, the gold miners would look for this quartz muscovite pyrite schist that was had been flushed with the pyrite, because that's also where they found gold. So isn't that cool? Okay. So we identified all the rocks. Step 1 is crack the rock. Step 2 is organize the rock into piles, felsic, intermediate, mafic, and weird. And then you could You could look at the list of rocks found in the province if you know where these rocks are found, and that'll give you a list of possibilities. You could just thumb through the pages of the book. The book. You can get this book on Amazon Books and have permission to use it. You just thumb through the pages in the book until you find a rock that looks like the one that you have, because these pictures are pretty good. They're pretty good. Another way is to focus with your hand lens on the rocks and say, what minerals do I see? And are these minerals felsic, intermediate, or mafic? Remember to scratch the black stuff with a nickel. That will go a long way to telling you if you've got biotite versus a more mafic mineral like hornblende or pyroxene. Okay, we'll keep doing this as long as it's fun. And, for me, it's always fun. All right, pop out.